Before we talk about the costing tool itself and what it is, I'd like to spend a minute just talking about why there was perceived to be a need for developing a tool like this. As many of you, I'm sure, already are aware, there's only one direction that codes and programs are going, and that's towards more energy efficient homes. There's generally accepted to be a goal of net zero by 2030 out there. In some cases it's an explicit goal, in other cases it's more aspirational, but we know we're not going backwards. The requirements and the markets are driving towards higher energy efficiency levels in houses, and that presents a challenge for builders to overcome. How do we deliver on that in a cost-optimal way, since home prices are obviously one of the other pain points that we come up against in the industry when we're trying to get these homes out into the market. So when we're exploring how to meet these more stringent energy efficiency requirements in houses, there are a lot of elements of the home that we have to take into consideration. Compared to a standard code-built house, there are dozens of upgrades that one could make to improve the performance of the house, but often these taken in isolation can already represent multiple different runs and levels. For example, the amount of insulation you put in your wall could vary dramatically. You might consider 4 or 5 different systems. But you might also be considering 2 or 3 different air tightness targets. You might be considering 2 or 3 different heating systems, trying to figure out what the optimal amount of PV to put on the roof is. And when you start to take all of these permutations and combinations together, you quickly realize that there are tens of thousands, if not hundreds of thousands, of possible combinations of upgrades that you could adopt as a builder or as a designer in your path towards a more energy efficient home. So we have to understand what kind of combinations of elements are possible, and we have to look at them with a larger lens, and I think it's important to put that out up front, that cost is not the only lens through which we evaluate the packages that we take out of this. There are still considerations of building science, comfort, durability, buildability. All of these sorts of things have to be considered as well. But today we're going to focus on cost and energy as the two kind of pillars that support the development of this tool. And this tool specifically will give you some insight into the relationship between costs and energy to start the discussion of those other things from a good place. So in my experience, and I think my experience here can refer more generally to energy advisors, we've traditionally worked with builders and designers in voluntary programs. R2000 has been around for longer than the name would suggest. The Energy Star for New Homes program has been around for 20 years at this point. Net zero homes are now out there as well. And historically, these have all been voluntary labeling programs that builders opt into. But as I mentioned just a moment ago, we are seeing that codes are becoming the new kind of voluntary standard, and obviously codes are not voluntary. So the importance of this work is more emphasized now, and it really means that we have to have a quick look at what our pain points are as we move to industry adoption across the board. So as an energy advisor working for builders in this space, there are a few things that I would describe as pain points in trying to deliver the services that I offer to my clients. Often we're dealing with limited time. We're up against permit schedules, foundation schedules, what have you. Trying to fit us into the design process at the right phase is something that is still being felt out in the industry. Not everyone has the same appreciation of at what stage they should be calling their energy advisor. Sometimes they're called as soon as the site is purchased. Sometimes they're called when they realize that they can't get their permit without an energy advisor doing an energy model. So we become a bit of a pinch point in the timing of delivery of our services to builders sometimes, and that can be a pain point. The software that we use to run our energy models, Hot 2000, is designed to run one house at a time. So when a builder comes to me and says, well, I'm interested in building an R2000 home or a net zero home, and I would like to explore all of my options, I can only run those options one at a time, and it's a manual process. That takes time. Time costs money, and there's only a certain budget for the fees, et cetera. Another big one is that we're often trying to develop our energy efficiency advice without a whole bunch of costing data that is specific to our client. And what I mean by that is if somebody comes to me and says, what's the price difference between an air source heat pump and a geothermal heat pump? I can say, well, geothermal is much more expensive, but I can't tell you what it's going to cost you. I don't know, if you're a custom builder or a volume builder, what your site conditions are like. There are a lot of things that influence cost that is specific builder to builder and client to client that energy advisors don't have direct access to, sometimes because it's proprietary, sometimes because builders don't know. And so trying to give advice on energy efficiency in the absence of good costing data to support the direction we're proposing is problematic, as you can imagine. Now, finally, as the last point shows, because of the limitations of this process, we usually end up exploring fewer than 1% of all possible combinations that are out there. Now, that's a little bit misleading because there are some options that we can dismiss because they're impractical for our climate or for the buildability of the home, but still, it's a very small number out of all of the possible combinations that we know to be out there for a house. Now, on the flip side of this, there are pain points for builders, and it's interesting the group we have here today because we're actually not builder heavy. I think there's a lot of people in supporting associations and supporting roles here today. So I'd be interested in getting some of your thoughts on what similar pain points to this could be from a builder's point of view when they're trying to get towards a net zero type performance in the house.
Capacity.
What do you mean by capacity?
Time to, I would find that in consolidated builder market model, one, you've got a condensed builder market. The second piece of it would be that due to that and with code change, consistently, we'll use the requirement for our 20 wall system recently. Everyone went to a 1-inch vault on the exterior. That became a nominal quick solution because it was easy. Rather than reassessing, if you were building a home in 2019 versus the home you built in 1980, what would you do differently today, rather than adding to what you already have?
Interesting. It's kind of the incremental improvements that are based on momentum rather than reassessing.
And it's a lack of time within their own industry to be able
to
assess that, and that's a capacity, the ability to assess the difference of what you do today versus what you've done since 1980 or 1990.
Yeah, really good.
Now the building industry is very slow, I agree with that. Like I've done ICF houses. So when I'm in the design process, it's a selling factor. Okay, this is what your yearly cost of 2,400 square foot house, your electrical, your heating, because the air conditioning cost is electrical. People forget it's not gas or oil. And it's just trying to sell people, because people are still not willing to open the pocketbook and pay energy.
Okay, so it's
I come across that all the time. It's a hard sell.
Hard sell.
And I would say to people that what you're building today is going to be very shortly expired. Like you might as well build what in 10 years it's going to be, because that's the value of a house in 10 years. Otherwise, you're just sort of left in the dust.
Right.
The technology is there. I'm always curious in what Europe is doing, because they're so far ahead of the game on from appliances to just technology and construction methods, because they don't have lumber, so they use other materials.
Right.
And one is
Yeah, so if I key in a little bit on what you're saying, something that I think is really important to highlight is this idea that what people are willing to pay for is a challenging thing when it comes to energy efficiency, and projecting that out into the future and getting people to understand what the implications are down the road. So we do have some. These are all really valid. There's a few others that I'll put up on the screen just to talk about what they are, and I think we've touched on a few of these. Too little time to consider many options. That's the capacity we talked about. Not being necessarily aware of all of the options that are out there. Sometimes, depending on who you have supporting this process, they may not bring all of the possible options to the table. So you might just have a gap, a knowledge gap. Sometimes, it's very difficult to project costs. It's more easy to evaluate costs after you've tried it once, and so it's very difficult to know ahead of time, well, how much am I looking at to try this net zero for the first time And as you said, trades are not pricing it necessarily based on what it'll actually cost. It's a difficult one. So, yeah, all really good points. So, I think we touched on a few things that are key to what we're looking at today. Time is a critical component of this. The faster we can look at a variety of options, the more advantageous it will be to everyone. Cost is obviously huge. Time costs, and then costs to build are related to energy efficiency at the end of the day. And energy efficiency is being pushed and adopted quickly enough that it's important to consider these things in a related way. So today we're going to look at a tool that is, as I mentioned, specifically focused on looking at the relationship between energy efficiency in a new home and the cost to build that home or the cost to own that home, which are being separated out for the sake of comparison. And the tool uses right now an approximated cost database, which is the result of some research that was done at a national scale using data from various markets and using costing expertise from sources like Yardsticks and Hanscom's, the costing manuals that are out there. So it is generic in the sense that we know all markets are not created equally, but we have to start somewhere. So the tool has some costing built into it that is tied to the underlying data. We're going to have the ability today to customize those costs as we see fit for our market today. We'll talk a little bit about how the tool is structured so you understand how it's working a little bit. We are starting off with HOT 2000 as our energy modeling software of choice. Everyone here familiar with that software, at least that it exists, not necessarily that you can know how to use it, because even the people who know how to use it have a hard time sometimes. It exists, and it is essentially the most commonly used energy modeling software across the country. And it is very good at predicting energy use in new homes and has absolutely no cost data built into it at all. So it has nothing to help us along this path today. But it forms the basis for what we're looking at with the tool today. So we know that HOT 2000 supports all of the voluntary programs. It is being adopted by codes and supports code compliance, but is limited in that it only evaluates upgrade scenarios one at a time and has no support for costing. There is a tool that has been developed called HTAP. It has been developed by Narcan, which is basically a programming language tool that allows for HOT 2000 runs to be automated. And this tool can take every conceivable optional upgrade that you would like to consider and run them automatically through HOT 2000 to generate hundreds of thousands of results and has costing data associated with every one of the upgrades that are built into the software. So this is kind of under the hood where all the data resides. And at this point in time, HTAP has primarily been used to support research and the development of codes because it's quite an advanced user type of interface. It's not really ready for public facing, nor is it meant to be. This is a research type tool. So it's important in that it generates the data that we're going to be filtering through today, because until we can have a data set to work with, the tool that we use to filter it has nothing to look at. So HTAP kind of sits under the hood. The costing tool today that we're looking at, it's still kind of in the beta phase, which is why you'll see that on your Excel spreadsheet, but it's designed to filter through these hundreds of thousands of HOT 2000 data runs that HTAP has produced and find the most cost optimal combinations for building and for ownership based on the costs that are built into it, and then to allow you to change those costs and to refilter the data as you change the costs to find other solutions that might come out of it. So it allows energy advisors and builders access to this data in a usable way with a user-friendly interface to allow us to start to customize this for our market and make these results specific to you and to us as we work together. So today we're going to be looking specifically at some net zero and net zero ready solutions within the tool. The tool, as you'll see, has the ability to set other performance targets, but for the sake of the exercises today, we're going to focus on those two. We're going to use an archetype home that is built in to the tool right now. and we'll talk a little bit more about what other home options you have available to you down the road with this tool. So the home we're looking at today is a 2,500 square foot home with a walkout basement. There's a picture of it right there. And all of the HOT 2000 run data that we're going to see is based on runs of this home today. So there it is. Looks pretty typical of a new suburban home, I think it's fair to say. And the baseline in this home, so baseline, I should back up a sec. Everything is going to be compared against a base case as we look at these tools, so that when we're talking about costs, we're talking about relative costs to base case as opposed to absolute costs. The idea there is that we're not talking about, we're trying to take off the table anything that is not related to energy efficiency and cost. So the costing that comes out of this tool is not affected by your choice of countertops or your siding choices or your roofing material. It is affected by what you choose to put in your assemblies or what you choose to use as your heating system. And it's being compared against a base case, which is based on the NECB from the National Building Code. So kind of a baseline performance for the National Building Code. Future versions of the tool will allow for customization of this baseline, but for the moment we are sticking with the National Building Code as the baseline against which we're going to compare. So you can see on the screen a quick rundown of the specifications for that house, pretty standard stuff that we would see. And the two cost scenarios that this will put out for us, as I mentioned, one is the cost to build, so this is what we're going to call today the capital cost of the home. And the second one is the cost to own. And this cost to own is going to be calculated by looking at the cost savings potentially or increases in cost of the utilities based on the heating system you have and the conservation of the home, so your utility bills, and the impact on mortgage payments to the homeowner as well. So we're looking at kind of a net calculation where, and you hear this argument quite a bit, I'm sure you're all familiar with it, you'll save enough money on your utility bills to offset the increased cost of your mortgage. This tool will prove or disprove that theory based on a combination of elements that you're looking at. So depending on your province, you can change the cost of those utility rates and the fixed fees of your utilities to make sure that you are not misleading a builder or a client with statements like that. So the basic process for using the tool, you start by defining your target. What is the energy efficiency target that you're aiming to achieve? You select from a series of energy conservation measures, or ECMs for short. We can't go through a workshop without defining some acronyms, so there's our acronym for the day, ECM. You can then review the costing that is associated with these energy conservation measures and adjust them if you see fit. And generate some cost optimal solutions based on that. And as I mentioned way back at the beginning, the output from all of this, once you get to that point, is meant to be kind of a signpost pointing you in a direction that's worth exploring in more depth. So the process that would come after today's workshop, which we're not going to get into, is you may end up with a solution that is interesting but doesn't tell the whole story. You'd then take that with your energy advisor into a more rigorous analysis in HOT 2000, but at least you've done a more high-level evaluation of the scope of options that are available before you get there. Any questions so far? It's a lot to take in. It'll make more sense, I think, when you see the tool, but happy to answer any if there are. Yes? Okay, shoot.
HTAP,
Mm-hmm.
how long does it take for a run?
I'm doing an experiment at home right now on a laptop that looks very similar to this one. It's running 320,000 HOT 2000 runs. It's going to take about 6 days. 6 days sounds like a long time, but if I was to sit down and do 320,000 HOT 2000 runs, you could call me in 15 years. I might be close. So I think the power of the computer makes a difference. I know that when Alex at Enercan is running these, he's often relying on remote servers and cloud computing solutions. And he's told me that they can get 1.6 million runs in about 3 days. So it's quite big. Not instantaneous, but much faster than manually.
Okay. Is there any planned to make it available to outside parties?
It is actually an open source code, so it's already available to outside parties. The challenge is that it's a Ruby scripting language, so you have to have some kind of programming wherewithal to operate the tool. The Canadian Association of Consulting Energy Advisors, CACE, is working on developing a network of professionals that are trained in the tool so that it can be available to builders who want to use the tool to evaluate their own housing. Please, yeah.
When you're making changes in here that will affect the thickness of walls, where is that extra wall thickness going? Is it going on the outside of the wall or on the inside of the wall, reducing the floor space?
It depends on what you select as your ECM, but it's a little bit, I suppose the practical answer would be it's going to the outside because we're not changing the interior volume of the model that's running. So because HOT 2000 doesn't work in thicknesses, it only works in effective R values, it's a little bit ambivalent to whether or not you're adding it to the inside or outside. That's why I like to highlight the fact that it doesn't tell the whole story. If this solution spits out an R40 wall as the optimal solution, you still have to look at that as a builder and say, can I build that much wall thickness on my site or on my lot? It may be a non-starter. And what we have the ability to do during the costing tool exercise is to avoid making selections that we know to be impractical. If an R40 wall is too much thickness for our application, we can simply exclude it from the list of options for consideration. If there's not any other questions, I'll jump right into the tool and give you a brief overview, and then we'll have a short break, and then we'll get right into the exercises and walk through it together where you get a chance to have your hands on. So, switch over to the tool.
So if you can, guys, follow along in the tool.
Yeah, we're not going to make any changes in this first run through. I'm just going to basically show you where everything is so that when we get to the exercises, you'll be a little bit familiar with it. So I'll try and kind of go slowly, give you a chance to look back and forth between my screen and yours. My screen is quite zoomed in so that you can see what I'm looking at. Well, I guess you can't see anything because it's still on the PowerPoint. There we go. But your screen may show a little bit more than what I'm seeing, so I'll try and walk you through it. So first thing to notice is along the bottom, we have several tabs. Archetype, optimization criteria, ECM selection, builder line items, and results. I'm starting on the archetype tab, so if your file didn't automatically open to that page, that's the one we're going to look at first. So I'll just zoom out for a moment to show you the overview of what's on this tab. So on this tab on the right-hand side, you can see the available archetypes. There are 4 available archetypes that are preloaded into the costing tool. These are homes for which that 1.6 million HOT 2000 run data set has been generated already. So they're available to the software to use. And they represent 4 different housing types, 3 single detached homes and 1 row house end unit home. That we can use to evaluate our options. So one of the simplest ways to make this tool useful today as a builder is if you're building a home that resembles any one of these 4, choosing the archetype that most resembles what you're building will give you some useful information to consider. So short of actually having a home that is specifically yours in the software, that's the next best thing that you can do is choose a home from this data set. There's a short description under each one of what that home includes. But if we look in the table on the left-hand side, you will see that after we've selected the archetype that we're using today, the Atlantic, you actually get more detailed information under the architectural takeoffs of what that home actually has in it. So it'll give you the above grade wall area, foundation wall area, below grade wall area, to give you more in-depth look at what that archetype actually represents for comparison against your own homes or your own archetypes, if that's useful. Fortunately, you don't have to know what zone you're in to use the tool, you just have to know what city you're in, and it will tell you what climate zone that city is in already. So there are, at the top, the fields in green are the ones that we can edit, and so the preloaded archetype has the 4 options in it. We're going to stick with the Atlantic, And the location, we're going to stick with Ottawa for today's experiments so that we all have comparable data. It's actually the only choice that we have loaded into the beta version of the software right now, but there will be other locations built in there as well. So that's all we need to know about the archetype page. That'll probably be the last time you see that tab today. Just wanted to show you what was on there. We're going to switch now to the optimization criteria tab, the second one. And on this page, we have the ability to kind of set the parameters for the costing study that we're going to look at today, starting with the target and moving into the costs related to utilities and the limitations of photovoltaics as we go. So if you can see my cursor on the screen, the very first one, the performance targets, is where we're going to set the energy efficiency target that we're going to use for the day. Again, we're not going to make any changes right now because our exercises are based on what's preloaded with the tool, but you can see that under the approach to net zero, you can choose net zero, which means an offset of generated energy on site equivalent to the consumption of the house on site. Net zero ready, which is the same equation minus the actual generation, so the ability to generate as much energy on site as consumption in the house. Or not applicable if you're trying to calculate to a target that's 20% better than a baseline, et cetera, that has no relationship to PV generation on site. There are a number of energy efficiency targets that are specific to either the CHBA's net zero ready labeling program, which is what we'll focus on today. The BC step code tiers are built into this as targets, and then there are some more generic targets of 20 to 70% savings, and those are savings over the base case. So in this case, savings over the NBC. And if you eventually have the ability to adjust the base case spec, it will be savings over whatever base case spec it is that you've defined. I should stop here and just ask, is everyone comfortable with the definition of net zero as we're using the term today? More or less, yeah? Pretty familiar with that? Okay. The base case option, there is also the ability to choose either regular or reduced plug loads, which is the third line. So net zero standard typically uses reduced operating costs, but there is the ability to choose standard operating, which would be regular as well. The second section, where it says net zero PV parameters, allows you to input the maximum PV generation capacity for your project. So this is not the number of panels that you can fit or the orientation of the panels. It's ambivalent to all of that, but it's based on how much energy whatever array you decide to install can generate for your project. This can be estimated by somebody who works in PV for you, or a lot of softwares will auto-generate this sort of thing. But you'll see that this has a big impact when we're targeting net zero, because it will push the software to find solutions where the energy consumption can be offset by this amount of generation. So right now we've got that set at 20,000 kilowatt hours per year and $2.1 per kilowatt hour per year in PV cost, which is the cost to install this much PV. So if you have different PV costs for your market, whether they're higher or lower, you do have the ability to adjust that here. And this will obviously be something that changes over time. We've seen PV costs come down, so very likely if we were going through this workshop next year, we would change this cost to an even lower number. So I think just from this discussion, it's pretty obvious how tricky costing is as an element to include in this sort of thing because of the variability and all of the outside influences. So the tool is meant as a way to navigate that, but not everything is going to give you everything. It's not foolproof, right? There are still local hurdles that you may face, but the idea is to make it flexible enough for you to work those in if you see fit, if you want to adjust those costs based on that sort of thing. I'm going to scroll down here just to keep moving ahead. The next section is for utility costs, and this is where you can input costs for gas and electricity that are broken down into a fixed cost, base cost it's called in this case, and the actual fuel cost or energy cost itself. So we know that Enbridge or Hydro Ottawa or any other utility has usually a fixed fee on your monthly bill that relates to connection or account fees or whatever it may be. And then there is a cost for the actual product that you're consuming, and you can enter those separately here. A topic that's come up in all past workshops is, can you account for rental equipment, which is something that a lot of builders are opting for these days. This is one of the ways right now that you could account for that by including the rental cost in the base cost of your monthly utility. Future versions, I think, are already pegged to have a more robust way to account for rental equipment, but this is one way to do it right now. And finally, at the bottom, you have an electric feed-in tariff section. If you are in a market that has a program available for FIT and the utilities are paying you for generation, you can put in the rate that you're getting paid for your generation here, and that will be taken into consideration in the costing. It's at 0 right now because, unfortunately, in Ottawa right now, that's what we're at. Down at the bottom, the final 3 sections of this tab are where you can have influence on some of the other costs that affect this process. Starting with the builder's costs, there's an ability to adjust the profit margin and overhead as percentages. You can also adjust the home buyer finances, the amortization rate or period of their mortgage and the interest rate. So as mortgage rules are changing, you have the ability to make adjustments here to impact the cost to owner calculation. And then there's a field for contingency if you want to add some costs to cover things like professional fees, what have you, just unforeseens, that is built in there as well. And that's calculated above and beyond the capital costs that the solution generates. The way this tool is using that data is it's using the amortization rate and interest rate, or the amortization period and interest rate, to calculate the cost on a monthly basis to the owner. So it's not important to know how long the owner stays in the house for the simple payback that we're looking at, but if you wanted to project that out into some sort of a payback period, you could take this data into that calculation as follows. So you'll see in the next tab what it spits out. It's going to give you a net annual cost to owner, which is going to be the difference in what their out-of-pocket is year to year, not over the life cycle of their whole mortgage. So after all of these numbers are filled in or left at default for our purposes, we can move on to the next tab, which is ECM selection, the Energy Conservation Measures selection. And I'm just going to zoom out to give you an overview of this for a second. So we have basically a left and a right side to this page. On the left-hand side are all of the options that we have available to us to choose for filtering the performance and the costs of our runs. It's broken down by category, envelope upgrades, window upgrades, air tightness upgrades, and then mechanical upgrades down towards the bottom. And then before I dive into that more deeply, on the right-hand side, you have 2 things that show one or the other. The first thing you'll see is the results of your optimized run, which we're calling once you do a run, we're calling it an optimization, and the result is your optimal solution. So once you've defined your parameters and you click optimize, this is the table that will spit out the package that it's recommending that you use. And it includes at the top an overview of what that package is, and down below an overview of the energy use and finances that it's going to spit out for that as well. There are 2 buttons kind of in the middle here, if everyone can see where my cursor is, that allow you to toggle between 2 separate tables on the right-hand side here. So right now we're looking at the optimization module. If we click on View Costing Module, hopefully that will work for me. There we go. View Costing Module gives you an actual line-by-line breakdown of one of the energy conservation measures that we've determined to look at on the left-hand side in more detail. And we'll get into this in a second, but I just wanted to show you where those is. So there's 2 buttons there to familiarize yourself with. Optimization mode will give you the outputs, and costing module is where we get into the detailed costing of an upgrade. So I'm going to leave it on optimization module for the moment and zoom in to give you an overview of the table in a bit more detail. If we look across the columns of the ECM table right here, you'll see a few different things. You have, first of all, we're going to scroll down to look at both roof insulation and above grade walls together. The first thing you'll see is the material options. Not all ECMs have material options available to them, but a couple of them do. In the walls specifically, you can see that the performance level choice in the first column defines an effective R value, and with a BAT defined, and exterior insulation in this case is generic. The drop-down menu under material options allows you to change what that exterior insulation in this case would be. You can choose between XPS, EPS, or mineral wool board. And the cost, depending on your selection there, will change because those materials all have different costs associated with them. So there are sometimes more than one option that you have to select to define exactly what R22 effective option you would like to consider in that case. The third column is the total upgrade cost of the measure that you're selecting, and this is based on the costing data built into HTAP, which I described earlier. This is the nationally kind of combined costing data feeding in to give us these numbers. And as I pointed out before, it's important to remember that these are incremental over the base case, and these are not tied into finishes in any way. So this is ambivalent to whether you choose brick or siding. It's simply the cost of upgrading your assembly that affects energy performance. Column E right beside that is the cost override column. And in this column, we have the ability to do a very simple cost override that will take precedence over the number defined in column D. So if I am in the attic insulation option, for example, I may decide that R40 fiberglass is less expensive than that, so I'm going to write 1,000, and the software will replace that number with $1,000 and use that in determining whether or not this is a useful upgrade to consider or not. I can delete that and it'll bring back the default value in the column before. Column F is the one that we're going to be playing with the most today. This is where you can say yes or no to whether or not you want the software to include this option when it's considering its most optimal configuration. So if you know, for example, that you would never use R80 because that's going to change the way you have to structure your ceiling to support that much weight, you can simply choose no, and it will not include any combinations that use R80 to achieve the energy efficiency target. Does that make sense? And finally, in the last column, view costing detail, type yes. In this column, if you choose any one of these ECMs and type yes into the column, and then click the big green button beside it, which you see says click to view detail costs, it's going to pull the data related to generating the cost for that ECM into that table on the right-hand side that I showed you a moment ago. So if I scroll over to the right-hand side and I click to view the costing module, this is what I'm going to see. So this table now shows me for the ECM we selected, which in this case was an R22 effective wall with fiberglass bats and XPS exterior solution. For every item in that wall assembly, it's going to give me a description of the item that's being costed. I'll just point this out up here, I think it's a little easier. So we have the layers in that assembly, the item that is being broken out, and then the unit costs for material or equipment, and the unit costs for labor, combining into a total cost. You have the ability in this table to override any one of these costs specifically. So you can get as fine-grained as you like in this. If you know, for example, that you pay a different cost for drywall than what's broken in here, you can change the cost per drywall from 25 cents a square foot to 22 cents a square foot. And you could change the cost of labor, let's say we pay more in this market, to 50 cents a square foot for labor. And if you update the costs, it will now use those updated drywall values in every assembly that uses drywall in the costing tool. So the cost of your ceiling drywall has now been affected. The cost of your basement wall assembly drywall has now been affected as well, if it's applicable in that case. At any point, we can also click on Restore Defaults to bring back the standard values that are built into this.
A lot of builders really speak in Imperial, so we want to make sure that we're using the language that they use, and that even estimators, subgrades, You want to try and get a price per cubic meter or square meter, it's like, yeah, good luck with that. So, I mean, yeah, certainly you can convert these after the fact. It's a little bit confusing, but yeah, that's something that we're looking into to make sure it's represented in both units of measurement.
So it says upgrade cost, but is it really upgrade cost? Because like, isn't drywall kind of in every assembly? Like, you know what I mean?
Right. It's a good question. I'm not sure the nuance there. If it's included in this assembly, it will include it in whatever other assembly uses drywall. I think that may.
So your upgrade is really your delta between your R16 effective and your R22 effective.
Right, and if there's a framing change, that may affect it as well. Yeah, it includes a lot of other layers. It's not isolating that energy efficiency upgrade, I guess, because it's trying to account for other layers that may go into it, but it is stopping short of the aesthetic customizations.
Right.
You said, where did you derive your costing data for price per square foot in this section?
It varies by element. It's a combination of a whole bunch of contracts that Enercan put out. So some of the data comes from costing databases like Hanscoms and Yardsticks. Some of it comes from Leap workshops in other markets where builders shared costs and they were aggregated in that respect. Now you have the ability to generate a result, save the result, and run another run in this case. So if you wanted to specifically dive into whether or not the choice of exterior installation was going to affect what the output is, you would simply run the tool a couple of times to do that. What the tool will give the builder is better information on what the possible impact to their buyers will be of those upgrades from a cost perspective. And then if the differentiation comes from the energy efficiency argument or the quality argument or whatever other argument you want to position that, it's supported by this. So we have seen evaluations done in these workshops where the cost to owner, considering the savings of electricity and gas and the cost of the mortgage, has actually improved as you went higher and higher towards net zero as opposed to incremental improvements, to a point where it would support an argument to a homeowner that if the cost of electricity doubles in 10 years, you will be saving money every year from that year forward. And that sort of statement is supported by what the tool will give you. At the end of the day, this tool is not.
So to the consumer, that's great. But what value add is that to the builder that's selling it?
To the builder, I think the value is going to be, it enables you to look at a lot of options in a very quick and easy way. So let's say I am a builder and I know where I kind of want to be. I can evaluate whether or not I want to invest in windows or I want to invest in wall. And that's what the tool is spitting out. And beyond that, it's kind of up to the builder to decide how they want to position the product.
I mean, it does come down to, and I'd love to get your thoughts on this too in a sec, but it does come down to a little bit whether or not you're being driven to look at this tool because you are being mandated by a code, or whether you are looking for options for differentiation. And the targets that you set within the tool may impact that output. But to be very clear, the tool is not restricted to builders going for net zero. It can also help you get to 20% better than base case, which could be step 2 in a stepped code, for example. So the idea, in setting the context of the outset, the idea is that we know that the restrictions are going to get tighter. And it's going to push builders, more of those 5,200 starts are going to be pushed towards higher levels of performance. And this, for a production builder, I think will help them answer the question, as Becca pointed out, of what is the most cost-effective option for me to get to that minimum performance level. Not everyone's going to sit back and say, I'm going to do this because I can sell a better home. Some builders are going to do it because they're being mandated. And I think it's useful in both cases, but with a different lens, if you know what I mean. There's a lot of consistency. As you pointed out in the pain points at the beginning, what we see most often is an incremental upgrade based on what you were doing before. Yeah. So if you were doing 2x6 framing, then it's 2x6 plus 1 inch, and then it's 2x6 plus 2 inches. And so that's the dominant assembly that we see in production homes at the moment. In custom homes, it varies wildly because there's a lot more flexibility in budget and in time for exploration. to have those discussions about building science and durability and comfort. So then we get into ICF solutions, we get into SIP solutions, we get into double stud walls and you know, exterior Roxol and all the kind of fun stuff that we enjoy talking about. But it's not common in the production sphere at the moment in this market.
So would you say then the builders have done like a ton of research to find the most cost optimal solution, or they found, you know, the one solution that's going to bring them over that line just to meet that target, so they can, you know, get those permits and then, you know, sell it under the banner of that mark?
Yeah, I mean, I think the comment about capacity was spot on at the outset, and that is what we see. It's not, I've yet had the luxury of participating in very many discussions where you sit back and say, okay, here's the target, let's start with a blank slate and see how we get there. The amount of work that goes into a production builder developing their suppliers, their trades, their unique costs, their schedules, makes it very difficult to pivot. And so incremental changes are the easiest to adopt, and we find that we're very often trying to evaluate between the relative performance improvements of incremental upgrades as opposed to wholly new solutions. That also goes back to, I think, what I was talking about at the beginning, limitations on our time and what we can present. We have to start with what the builder is most interested in, that is most relevant to them. Having the ability to sit down and say, okay, well, we've done all those runs, and then we did 16 other runs or 26 other runs, looking at the impact of a whole new mechanical system or a very different approach to windows, changes that discussion, allows you to say, okay, have you considered going this way over here is going to let you change all of these other things to your benefit, potentially, I don't know.
And so, would you say that there's a possibility that maybe some of the builders, the way they're building now, is not necessarily cost optimal?
Absolutely, but we don't know what we don't know, is a fair way to put it, right? Yeah. Charles, do you have something?
Your question about what's the advantage of a builder to spend more money up front and trying to sell that product against a competitor who builds to code as opposed to going beyond code, right?
Yeah, because it's capital cost today versus lifetime value of the home, which the builder doesn't care about and shouldn't care about in reality,
Right.
for a sales perspective.
But then the lady sitting beside Rebecca, what is your name?
Carolyn.
Karen. You mentioned something interesting. You mentioned if somebody's going to try to sell that home in 8 or 10 or 12 years when the standards will move up and this home is an energy guzzler. So that portion of the life cycle valuation is lost, and when we do an analysis, first cost to build, right, which is a builder's perspective, and then we have the person who's buying, who's got an approved mortgage payment of so much a month. He's trying to get as much as he can, tangible square footage, countertop, as he can for that value, and that's how he looks at things. And energy is a nice thing to do, but they translate that into energy costs, mortgage costs. But there's a lot that we miss in this, and in an environment where we probably can assume that energy costs are going to increase over time. When we look at the savings that this tool does, and we're going to improve on the tool to include what I'm about to talk, and I think it might provide builders with a differential if we can educate the different professions involved, the banking, the real estate agents, and the builders and the consumers about the value, and the insulation people here are going to like what I'm going to say. When you put a sheet of styrofoam behind your foundation wall or under your slab or add an insulation in the attic, you are actually building a power plant in terms of avoiding energy losses in the future. And energy costs are only going to increase, so the value, when we do an analysis for a mortgage of 25 years of 4%, this is a time study, economic time study, and nobody takes into account the residual value of that insulation in the wall. It's got no moving parts, it's got a life expectancy of over 100 years, fiberglass, styrofoam. So let me illustrate the concept here. Let's say a young couple buys a home now, assuming that they can spend the extra money, and they build to a 2030 code, net zero, right? And at the end of 20 years, they want to sell that home, and all the houses are at that level, and they can sell that home for a better price than somebody who would have built a house in 2019 using to the 2015 code or whatever is enforced now. So this house in 20 years from now will be an energy guzzler, right? So somebody's gonna look at that house, they're gonna look at a house that was built also in 2019, but with net zero. And that house is gonna have an inherent value to it, an attribute to it, because of what's behind the wall and nobody can see. And that's cost. So if you were to look at here, right now we're looking at year 1 to 25 in terms of savings, at a constant energy savings rate. We probably can assume that the energy is going to increase. So there's an additional cash flow positive or avoidance of expense that is not built into our analysis. And at the end of 25 years, from year 26 to 50, if we have maintained that home, and we can expect those ECM values measures to have a longer expectancy than 25 years. All this energy savings over the next 25 years, you bring that to net present value in year 25. That's a huge amount of money. In other words, that insulation has got a very big value in 25 years, bigger than it has today because energy costs will be bigger from year 26 to 50. And that's an amazing value when you consider that. Now, if we can educate, all the people involved in the decision of building a home about that value, that built-in value, it makes spending more money now an investment with a rate of return bigger than anything you can get financially. Because when you put in, where else can you spend money? That's going to be on something that's going to be worth more in 8 years from now, in 12 years from now, in 25 years from now. And that's what your insulation level increase is worth more in 25 years than it is worth to do when you put it in. That's an amazing.
So I'm going to suggest that in the interest of moving along with the demos, this, fantastic discussion. What I would like to point out in this discussion is that having information about the relationship of cost energy performance enables this discussion. And we can have a more intelligent discussion with each other about what is the best way to appraise this 25 years down the road versus today, once we have a starting point, and that's what we're really looking at today. So just to bring us back, please carry on these conversations during the breaks and after the fact, and at the end we'll have the chance to reflect on some of this. But I'd like to get into actually using the tool so you can see how, if you'd like to do a 10-year out projection on what energy costs will be, the tool will let you do that sort of thing. So just before we take a short break, I'm going to set this tool running the first optimization. I'll just show you how to do that. So I'm switching back on my last tab here to view the optimization module. And with all of the options left at their default, I'm going to click to run the optimization. And this is when the tool will actually start to filter through all of the results and find the most cost optimal solutions for these two things. So this will take a minute or two. It's quite quick, but since we've had such a great discussion so far, I'd like to give everyone a chance to have a washroom break, grab some coffee, grab a snack, and in about 5 to 10 minutes, we'll come back and we'll look at the results of this and get right into the exercises.